Welcome to a presentation on crude unit simulator. The simulated crude distillation unit consists of feed pump which takes up crude oil from storage tank and sends it to the unit, preheat exchangers, desalter, booster pump, preheat exchangers which heats the crude up to 250 degrees centigrade, crude furnace which consists of two passes, fuel oil automizing steam. The fuel oil flow is controlled by a pressure controller cascaded to the furnace outlet temperature, which is maintained at around 360 degrees centigrade. The heated crude, which is partly vaporized, is sent to the atmospheric column where the vapor travels up. Based on the density, different fraction of the vapor settles down at various zones of the column. The unvaporized liquid is collected at the bottom of the column and sent out as RCO, reduced crude oil, to the storage tank. The bottom flow is controlled by flow controller cascaded to the bottom level controller. The uncondensed vapor goes out of the column, is cooled by air fin coolers and condensed by condenser. The condensed liquid is collected in the reflux drum. Uncondensed vapor is sent out to flare through column pressure controller, which is maintained at around 1 kg per centimeter square. The condensed liquid is partly refluxed back to the column through a flow controller cascaded to the column top temperature controller. The distillate product is sent to stabilizer for separating them into LPG and stabilized naphtha. The stabilizer has steam driven reboiler to vaporize the feed. Stabilizer pressure is maintained at 11 kg pressure. Top vapor is condensed by condenser. The reflux dome collects the condensed vapor. Reflux is sent back to the column through flow controller cascaded by column top temperature controller. The distillate product is called LPG, which is removed through a flow controller cascaded to the drum level controller. The bottom product preheats a feed and then it is sent out to storage as stabilized naphtha by a flow controller cascaded to the column bottom level controller. The atmospheric column has got 3 pump arounds to maintain the temperature profile: top pump around, middle pump around and bottom pump around. These pump arounds or liquids are cooled by crude oil so that a column temperature profile can be maintained. The side products are drawn to the side strippers, heavy naphtha, kerosene and diesel. Where steam is used, MP steam is used as a stripping media. The stripped products, heavy naphtha, kerosene and diesel, are removed from the strippers by product pumps and flow control valves. Let us now illustrate a few of the critical malfunctions. The malfunctions are divided into two groups: failures and disturbance. The malfunctions are divided into two groups: failures and disturbance. Failures are grouped into various pages like pump failures, utility failures, leaks and miscellaneous failures. Disturbance are again grouped into feed property, heat exchanger fouling, furnace section disturbances and utility disturbances. Let's take the first example, the crude composition change. The injector can change the crude composition by changing the percentage of heavy in the crude. The crude is a mixed crude, 50% heavy and 50% light. So if instructor changes the crude composition, say 30% heavy and 70% light, so we will start seeing changes in the plant. The crude oil vaporization will get affected because the crude oil has become lighter, and that will change the outlet temperature, which will be changing the fuel consumption. Then the crude oil vaporization, since it's changing, the column profile, temperature profile, vapor traveling up, bottom flow rate, all will get affected. So we will see the impact of the changes. But bottom flow is around 58 cubic meter per hour. It should keep coming down. Similarly, product top flow, which is going to stabilizer, is 138, 139 cubic meter per hour, and that should increase because the feed crude has become lighter. And there you will also see disturbances in the side products. So to observe the effect faster, we can run the simulator faster than real time. Five times real time, and let's see what happens. The furnace outlet temperature is changing, therefore the fuel consumption will be reduced because you are lowering the temperature, so which is what is expected, because the crude is lighter, so it requires less heating. So the column will see the level dropping in the bottom, which results into reducing the bottom flow rate. Top level will start increasing, which will result into more draw to the stabilizer column. We can also observe the parameters against the design value, current parameters against the design value in the instructor PV summary page. So we'll see the reduced crude from 60, it is coming to 55.48 at present, and it keeps going down. The heavy run down, reduced. Then we have the other changes which are expected, like product qualities are also displayed here, IBP, FBP as various products. You will see these also gets affected. Diesel recovery is more because its whole thing is more lighter. Product IBP, FBP all will reduce because of the lighter crude. See the top product, which is going to stabilizer, is increasing, which will basically, and bottom products keeps going down from 60 to 50, and the stabilizer feed will change, which will result into change in LPG and naphtha yield. So the overall material balance in the plant will change. The side stripper, since we are not adjusting the product flows, they are under flow controller, the stripper level will be adjusted. So basically the column temperature will also be changing, will become slightly lower than the design value, draw temperatures. So all the draw temperature has come down because you are not changing the draw flow rates, but the crude has become lighter. So we should have drawn more product so to maintain the temperature. Since the temperatures are going down, we will also have impact on the product quality, which are basically IBP, FBP, and they would have some impact. They will have lesser IBP and FBP, and diesel recovery will be slightly more.